Dr. Sadhana Singh. It's my last chapter on polynuclear hydrocarbon, and it is about derivative of anthracene, and it is anthraquinone. The anthraquinone, which has two carbonyl group on anthracene ring, which are present at 9 and 10 position, it is known as anthraquinone. It can synthesize by anthracene. The oxidation of anthracene with nitric acid, chromic acid, vanadium oxide at 400 degrees centigrade gives anthraquinone. So the oxidation of anthracene gives anthraquinone. The next reaction is by Friedel and Kraft reaction. In Friedel and Kraft reaction, benzene react with phthalic anhydride in the presence of aluminum chloride. The bond here break from here, broken, and it gives the CO as a carbonyl ion and CO minus. This CO, which act as an electrophile, attack on benzene ring and give the orthobenzyl benzoic acid. This orthobenzyl benzoic acid on reaction with sulfuric acid eliminate water molecule and anthraquinone is formed. The next reaction is by Diels-Alder reaction. In Diels-Alder reaction, the naphthaquinone react with butadiene. The addition take place here, and the terminal group of butadiene terminal double bond of butadiene shifted from 1,4 to 2 and 3 carbon, and we get this addition compound. This on oxidation gives the anthraquinone. So these are the synthesis of anthraquinone by oxidation of anthracene, by Friedel and Kraft reaction, and by the Diels-Alder reaction. The properties of anthraquinone. Anthraquinone is a yellow solid. Its melting point is 268 degrees centigrade, which shows it is quite stable compound. It is insoluble in water and soluble in organic solvent like benzene, etc. As far as chemical properties, it undergoes two types of reactions: reduction reactions and electrophilic substitution reactions. The reduction reaction of anthraquinone are the anthraquinone react with ammonia in the presence of zinc dust, it gives anthracene. Anthraquinone react with ammonium hydroxide in the presence of zinc dust, it gives 9,10-dihydroanthenol, in which one carbonyl group converts into the enol group and one carbonyl group into the CH2 group, and we get 9,10-dihydroanthenol. The reduction of anthraquinone with zinc dust in the presence of a base, it gives anthraquinol, in which both the carbonyl group convert into the enol group and anthraquinol is formed. This on isomerization also gives oxaanthenol. One hydrogen shifted from this group to this carbon, it converts into the CO group, double bond shifted, convert into CO group, and the keto-enol isomerization take place. Another reduction reaction is the anthraquinone react with HCl in the presence of tin, it gives anthrone, in which one carbonyl group converts into the CH2 group. This anthrone also undergoes keto-enol tautomerization, and from keto to enol form, it gives anthrone to anthenol. Another reduction reaction is anthraquinone react with HCl in the presence of tin and acetic acid, it gives the dianthracene. Dimerization take place and we get the dianthracene. So these are the reduction reactions of anthraquinone. Next is electrophilic substitution reactions of anthraquinone. In anthraquinone, two carbonyl groups are present which deactivate the ring. So The electrophilic substitution reaction cannot take place easily in anthraquinone. The anthraquinone doesn't give Friedel-Crafts reaction, and halogenation reaction can also not take place directly. The two reactions, electrophilic substitution reactions, which take place in anthraquinone are nitration and sulfonation. The nitration reaction of anthraquinone is the anthraquinone react with nitric acid in the presence of sulfuric acid. The nitronium ion is formed which attack at the number 1 carbon atom, and the hydrogen is replaced by the nitronium ion and alpha nitroanthraquinone is formed. This alpha nitroanthraquinone further undergoes nitration reaction and we get the dinitroanthraquinone. If the nitro group attached at 8 carbon, then we get 1,8 dinitroanthraquinone. It can also attach at 5 carbon, so we can get 1,5 dinitroanthraquinone. The alpha nitroanthraquinone also gives alpha aminoanthraquinone by the reaction of alpha nitroanthraquinone with ammonia. The NO2 group reduced to the NH2 group easily, and alpha aminoanthraquinone also obtained. The next is sulfonation. The sulfonation of anthraquinone with sulfuric acid and mercury sulfate at 120 degrees centigrade. The sulfonyl group attached at number 1 carbon and we get the alpha anthraquinone sulfonilic acid is formed. This alpha anthraquinone sulfonic acid further undergoes sulfonation and we get the product bisulfonilic anthraquinone, in which two sulfonyl groups are present, one at 1 carbon and another at 8 carbon. So it is 1,8 alpha anthraquinone 1,8 bisulfonilic acid. And if the sulfonyl group they are present at 1 and 5, then we get the alpha anthraquinone 1,5 disulfonilic acid. The anthraquinone also react with fuming sulfuric acid at 140 degrees centigrade. Then the sulfonyl group attached at number 2 carbon and we get the beta anthraquinone sulfonilic acid is obtained. This further undergoes sulfonation and give the disulfonilic compound. Two sulfonyl groups are present. There are two types of compound. In one, the two sulfonyl group are present at 2 and 6. So we get the beta anthraquinone 2,6 disulfonilic acid. If the group are present at 2 and 7, then we get the 2,7 disulfonilic anthraquinone. The alpha anthraquinone sulfonilic acid can also react with calcium hydroxide. If it reacts with calcium hydroxide at 180 degrees centigrade, the sulfonyl group is replaced by the OH group and we get the alpha hydroxy anthraquinone OH minus. Substitute the sulfonyl group and it is known as nucleophilic substitution reaction. Similarly, alpha anthraquinone sulfonilic acid, if it reacts with chlorine, then we get alpha chloroanthraquinone. The anthraquinone can also use for the synthesis of dye, and that is alizarin. So alizarin dye can also synthesize from anthraquinone, and the reaction is the anthraquinone react with fuming sulfuric acid at 140 degrees centigrade. We know the beta anthraquinone sulfonilic acid is formed. This beta anthraquinone sulfonilic acid, when react with sodium carbonate, the sodium salt of beta anthraquinone sulfonilic acid is obtained. This on reaction with NOH, the sodium oxide group is attached at carbon 1, and then this compound on reaction with potassium chlorate in the presence of NOH, the sulfonyl group is replaced by the sodium oxide group and we get the sodium alizarin. That is alizarin is formed and that is sodium salt of alizarin is obtained. This sodium salt of alizarin, when hydrolyzed with sulfuric acid, we get the dializarin. So, the use of anthraquinone is that it is used for the synthesis of dyes, and it is all about the anthraquinone and polynuclear hydrocarbon. Thank you.